So let's solve power stages in DC motor. Okay, now this will be the power stages in our DC motor. First is, of course, we'll have our input power. For in this case, our input power will be our electrical input. So we would put power in the terminals of our generator. So we will call this as our P in is equal to our VT multiplied by our IL, or the terminal voltage multiplied the current in our I in, I should say. So I in, or the input current, okay, or VT multiplied by IT, input terminal voltage in our current the terminal, okay, or our input voltage. So V in multiplied by my I in. And then from this, next power stage will be our output in our armature circuit, okay, so, or our driving power in the armature. Or usually this will be your PM, or P of the motor, which is equal to our EM, or our EB multiplied by our IA. So EM means the energy, the voltage in the motor. EB is similar as this one, which is our back EMF, or our brake EMF multiplied by our IA. And then lastly, we have our mechanical power developed, okay, or our mechanical output. So from here, there will be losses. In your power input, of course, there will be your losses in your copper losses. This will be from or the losses inside the machine, okay, which is usually it is based on what type of the connection will be the motor that you are using. Next, after this, if you already subtracted the copper loss from your P in, the next thing is your friction and iron losses. Iron and friction losses. These are your mechanical losses. Okay. Next, of course, after that losses, you will have your mechanical output. Usually, your EBIA, this is your PA, right? Or the power that is produced, or that is given off into your armature in order for the motor to create a mechanical output. Usually, we will have, or we will use our formula PA is equal to 2 pi TA multiplied by N all over 60 in order to solve for our armature torque. Now that armature torque, since we have our iron and friction losses, so of course there will be losses from that specific power output of our armature, okay, so in which we'll have our T shaft, wherein the T shaft is the mechanical output of the motor, in which we may say that our P shaft is equal to our PA minus these losses, minus power that are lost from our iron and friction. Okay, so this will be your P shaft, which we will use in order to solve for the output torque or the shaft torque. 2 pi TO N all over 60, or this can be equal to 2 pi T shaft n all over 60. Okay? Now, of course, there are efficiencies. So, as I have said in our previous discussion, our NC or our commercial efficiency or overall efficiency is of course equal to, for motor, we have our mechanical output or the output of the motor, mechanical output all over our electrical input. Okay? Or, right, this is equal to our mechanical input, mechanical output divided by mechanical output plus power in our iron and friction plus our EBIA plus our copper loss. Okay, but I will just check this one. Mechanical output plus our iron losses will be our EBIA plus my copper loss. Okay, so I will take this out. This is my EBIA. Okay, so of course mechanical output plus IF or PIF, which is our iron losses, plus my copper losses. Okay, next is our electrical output. Okay, so we have mechanical output. Efficiency of the mechanical output is of course equal to mechanical output divided by our driving power in the armature. Okay, or our electrical output. So our driving power in the armature. So driving power in the armature. Or this is simply equal to mechanical output divided by EBIA, or this can be equal to EBIA minus P of your iron and your friction losses all over EBIA. Lastly is our electrical efficiency. Is of course equal to our driving power in the armature, driving power in the armature divided by your electrical input, or in equation this will be equal to your EBIA divided by your I in multiplied by your VT, or this is equal to your EBIA all over I in V in, or this is equal to our EBIA multiplied by your P input, right? Now there's still another formula for our NC. Okay, so this is equal to our mechanical output. So we have electrical input minus your copper loss minus your iron and friction loss divided by your electrical input, which is equal to your V in multiplied by your I in. Okay, so those are just some formula that can be used in order to solve your power stages in your DC motor.